Hello everyone, myself Mrs. Archana Matre, lecturer in Electronics and Telecommunication Department. We will continue with the first unit of EMI, that is Fundamentals of Electronics Measurement. What are the learning outcomes of this video? The learners will be able to understand instrument characteristics, static characteristic of an instrument. Now in first video we will see the static characteristic like accuracy, static error and precision. Now we will see the different static characteristic. What is the static characteristic of an instrument? The static characteristic we will define as a fixed characteristic which does not changes with respective time. That characteristic is called as static characteristic. And depending upon the static characteristic, the performance of the instrument is decided. Now next characteristic is range. The region between the limits within which an instrument is designed to operate for measuring, indicating or recording a physical quantity is called as the range of the instrument. The range is expressed by stating the lower and upper values. Means how you can define the range of the instrument, the lower value of the instrument and upper value of the instrument. That is nothing but a range of the instrument. Suppose we will take an example of voltmeter. If you take one voltmeter for which the lower reading of voltmeter is 0 volt, that means voltmeter shows the reading from 0 volt and the highest reading, that is upper reading of the voltmeter, is suppose 100 volt. So 0 to 100 volt is nothing but the range of that instrument. Like that, if the instrument maximum reading is 10 volt, then 0 to 10 volt is the range of that voltmeter, range of that instrument. Now next characteristic is span. Span represents the algebraic difference between the upper and lower range values of the instrument. That means if your voltmeter's lower value is 0 volt, upper value is 0 volt, then the difference between these two is nothing but your span. 0 and 100. 100 minus 0 is equal to 100 volt. 100 volt is your span of that instrument. Okay, the algebraic difference between the lower value. Most of the time instrument lower value is the 0 and higher value may be different. The algebraic difference between the upper and the lower range value is nothing but your span of that instrument. Now next characteristic is repeatability. How you can define repeatability? The ability of an instrument to produce output readings when the same measurement value is applied to it under the same condition and in the same direction is called as repeatability. In simple way, what is repeatability? Suppose you can take one instrument, the repeated input you can apply to it, that instrument again and again. It is nothing but the repeatability. Here you can see the measured value. Measured value, that means nothing but your input. Same input is applied to the instrument under the same condition and the same direction is nothing but a repeatability. That means in repeatability your measurement value, that is your input value, should be repeatedly applied to the instrument under the same condition and the same direction. That means same input is repeatedly applied and instrument output reading will be checked. That is called as repeatability. Now next characteristic is reproducibility. Reproducibility is the reproducibility of an instrument is the degree of closeness with which same value of a variable can be measured at different times. Here what we can say, the reproducibility, that means the same output should be produced. Same output should be produced when the input is repeatedly given to the output. That means suppose we'll take a voltmeter and we will apply the input of 5 volt, and suppose the output of the instrument should be 5 volt. So repeatedly if the input is changes, then the output of the instrument voltmeter should be 5 volt. That is nothing but a reproducibility. Same output should be measured at a different times. That means in repeatability the input should be same, and reproducibility your output should be the same. Next characteristic is resolution. Resolution, how you can define the resolution? If input to an instrument is varied slowly from any arbitrary value that means any non-zero value, the output does not change at all until a certain increment is exceeded. This increment is called as the resolution of an instrument. That means what happened? Suppose we will take the example as a voltmeter. If you started applying some input to the voltmeter, voltmeter must show any reading output. If you increase the input, then voltmeter output should be increased. Ideally, if you given the input, there is some output shows on the voltmeter. But sometimes what happened, if the input of an instrument is varied slowly from any non-zero value, then the output does not change for some time until a certain increment exceeded. The output shows the reading 0. This increment is called as the resolution of the instrument. And after crossing the resolution, if you change the input, then the output start increasing or decreasing according to your input. Next characteristic is linearity. Linearity, how you can define linearity? Linearity, an instrument is said to be linear if its output is linearly proportional to the input. You can see here graph. In this, x-axis is your input and y-axis is your output. Okay, if you increase the input, your output should be increases linearly. This is the linear characteristic. If it happens, then your instrument said to be linear. If you increase input from 0 to 1 volt, then your output should be increased from 0 to 1 volt. Directly proportional to each other. Input is directly proportional to output. If that characteristic is occurs, then you said that your instrument is linear instrument. Now next is a sensitivity. Sensitivity is defined as the ratio of change in output signal to the change in input signal. Here you can say the input signal QI and your output signal is QO. Suppose this is the characteristic of the instrument, performance of the instrument. You will take a slope of that instrument. This is delta Q0 and this is delta Qi. The ratio of sensitivity, how you can define the ratio of change in output signal to the change in input signal is nothing but your sensitivity of that instrument. Now next characteristic is drift. Drift is an undesirable change in the output over a period of time that is unrelated to the changes in output. Now drift is classified into two types. First is zero drift and second is span drift, or you can say sensitivity drift. Now we will see one by one. First we will see the zero drift. Now zero drift, if the entire instrument calibration shifts by the some amount, this shifting is known as the zero drift. Here you can say in this graph, this is the input quantity, on y-axis output of the instrument. You can say the dotted line, this is the normal characteristic of the instrument, and the plain line is the characteristic due to zero drift. That means here the entire instrument calibration and entire instrument characteristic shifted upward by some amount. By some amount, which amount? X amount, it will shifted upward due to the zero drift. That is called as the zero drift of an instrument. Now next we will see the span drift or a sensitivity drift. If the entire instrument calibrations shift along upward scale, then this shifting is known as span drift or sensitivity drift. Here the calibration shift upward along the scale. Here you can see this is the input quantity, x-axis, on y-axis output of the instrument. This is the normal characteristic, linear characteristic, and because of the span drift or sensitivity drift, the normal characteristic shifted upward along with the scale, then that is because of the sensitivity drift. In zero drift, what happened? The entire characteristic is shifted as it is, and in sensitivity drift, what happened? It shifted upward side along the scale. Then that is called as the sensitivity drift. Now next characteristic we will see, that is the dead zone of an instrument. To understand the dead zone concept, consider an ammeter of 0 to 50 ampere range. Now current through the ammeter is increased from 0 to 1 milliampere. The pointer may not show a deflection. If the current is further increased to such a value that the pointer just deflect, we can say the dead zone is crossed. Within the dead zone, the ammeter pointer does not deflect. So the dead zone is the largest change of the input of a measured variable to which the instrument does not respond. That means how you can define the dead zone? Suppose you can take any of the instrument. The dead zone, within the dead zone, your instrument does not show the output. If 0 to, here we can say 0 to 50 range ammeter we will consider. If we increase the input 0 to 1 milliampere, it will not show the reading. That means from 0 to 1 milliampere, your instrument has a dead zone. After you cross the 1 milliampere, your pointer should deflect. That means your dead zone is crossed. Means within the dead zone, the instrument will not deflect, will not show any reading. So that is nothing but a dead zone of an instrument. Thank you.